Have you ever wondered how a pendulum works? What makes it swing back and forth, and why does it eventually come to a stop? Today, we're going to unravel the mystery of the simple pendulum, a fundamental concept in physics that has fascinated scientists for centuries. Imagine a small weight or mass attached to a string or rod that is fixed at one end. This is the basic setup of a simple pendulum. When the pendulum is at rest, the mass hangs straight down. This is what we call the equilibrium position. It's where the gravitational force pulling the mass down is perfectly balanced by the tension in the string or rod. But what happens when we pull the mass to one side and let go? This action displaces the mass from its equilibrium position, setting the pendulum in motion. The angle of displacement is measured from the vertical line passing through the equilibrium position. As the pendulum swings back and forth, it completes what we call an oscillation. The time it takes for the pendulum to complete one full oscillation from one extreme to the other and back again is called the period. It's a fascinating fact that the period of a simple pendulum depends only on the length of the string or rod and the acceleration due to gravity. If you're curious about how to calculate the period of a simple pendulum, there's a handy equation for that. The period, represented by the letter T, equals 2 times pi times the square root of the ratio of the length of the string or rod, represented by the letter L, to the acceleration due to gravity, represented by the letter G. In simpler terms, T equals 2 pi times the square root of L over G. You might think pendulums are just a physics concept, but they're actually all around us. Think of the pendulum in a grandfather clock, swinging back and forth to keep time, or a swing set in a park, where the seat hanging from chains acts like a pendulum. Even a metronome used by musicians to keep a steady tempo operates on the principle of a simple pendulum. Now, it's important to remember that the simple pendulum model assumes ideal conditions, like a massless string or rod and no air resistance. While these assumptions may not hold true in the real world, the concept of a simple pendulum still provides a useful approximation for understanding the motion of swinging objects. So, the next time you see a pendulum swinging back and forth, take a moment to appreciate the simple yet profound physics at work. From the equilibrium position to the period equation, a simple pendulum is a beautiful example of physics in action.